Good evening, my dear NEET warriors. This is your Capto, and we are in the NCERT Decoded mini series, which we have been doing for the last 1 week, where behind the NEET, I would say, or rather, in between the lines of your NCERT, there are some hidden concepts or some questions which you might be ignoring, or you might feel that okay, it is not so important, but then suddenly NTA decides to put a question bang on in the NEET examination. So let's test your concepts. Obviously, if you are preparing for boards, this will be like a very good quick revision also for all of you. So let's go to the problem solving. Enough of theory, and you guys were asking, sir, let's do some questions. And here we are, bang on to the problem solving. Welcome, Sushmita Prakash. Hello, Krishna. Hello, evening star. Good evening. Yes, I'm very good. Nice to see you guys back. And all my old minions, lovely, neat future doctors and warriors are back over here. And those of you who do not know me, yes, this is your Capto. I have been teaching for more than 13 years. I did my BTech from NIT Nagpur, did my research from IIT Bombay. I studied, for JEE and almost got full marks in physics. And I always loved physics. And yes, I saw my interest, or rather discovered my interest in teaching after working in software industry for almost like 3 years. So here I am for more than 13 years. I've been teaching and sending the kids to their dream colleges. And this year, obviously, it's your turn. So let's go to the problem solving. And I hope you have smashed the like button. If you have forgotten, do that right now. And if you have forgotten to subscribe, do that also right now. Because this is the #1 NEET English channel in the country. Yep, long time no see. Happiest evening. Wow. Looks like it's really a happiest evening because you guys are seeing me after a bit. And let me tell you, I will update the PDF after the session is over in the description box itself, just like we have done it for any other session over here. And looks like some cool series, Bio 360 Club, my God, has been launched by your Basra sir and Gopika ma'am. So do not forget to check that out as well. And yes, the Predictor series by Diksha ma'am for inorganic separate, organic separate, and for physical separate. 3 days, 3 different modules of your chemistry being covered. So make sure you're attending those classes as well. Okay, cool. So let's begin with the class. Subscribed, liked already. Here is the first question. Soap bubble has a negative charge. What do you think will happen to its size? Okay, let's imagine if you have a soap bubble like this, it has a negative charge, means that it has, let's say, electrons like this over here. What will these electrons do? They don't like each other. They will begin to repel each other. Isn't that so? What will they do? They will begin to repel each other, because like charges, negative, negative, positive, positive, will repel. And because of the repulsion, what will happen to the bubble? Yes, obviously the bubble's size will increase. Hence, the correct answer for this particular question should be increase. Let's see how many of you wrote option A, increase. Wow, very good. Sushmita was the first one. Krishna, very good. Very good, Disha. Very good. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. What about Q, R, S, T, U, V, W, X, Y, Z? What happened to that? Or is that username limit? Oh, okay. Okay, there we go. All right, next question. The electric field due to a dipole at an axial point. Electric field due to a dipole varies as which particular power of the distance. So if you have a electrical dipole, if you have a electrical dipole and you are at certain distance r, and this is basically an axial point, then the electric field over there, if you remember the formula, that's it. It was 2 times that Coulomb constant dipole moment divided by r cube. So it is inversely proportional to r cube. Option B for biology. Wow, very good, very good. Look at that spam. Very good, Krishna. Very good, Sanju. Very good, Susmita. All right. Very good, Kumkum. Awesome. Awesome, Disha. ABCD also knows the formula. Very good. B for beautiful, Captain. Oh, it should be beautiful, Gopika ma'am and beautiful Diksha ma'am. For guys like Baswa sir and me, it should be handsome. H for handsome, Baswa sir and Shreyas sir. Yes. Thank you guys so much. Means a lot. Electric field, yeah, this is done. Okay, what is the next question that we have? A particle having charge Q1 exerts force, electrostatic force on Q2. If the particle having charge 1/4 is placed between them, then what will happen to the force between Q2 and Q1? Okay, so let's understand. There is this Q1 charge and Q2 charge, and what happens is between them there is some kind of electrical force. Let's say I call it as F. Okay, now what happens? Another third charge Q1 by 4, Q1 by 4 is placed. They are not asking what happens to the net force, rather they are asking what happens to the force between them. That will never change. Yeah, this guy will also apply force on both of them, but the pair force between Q1 and Q2, that will not be affected. That is superpositioning theorem. If Pandu loves Champa, Champa loves Pandu, if Laddu comes in between, the love story between Pandu and Champa will remain intact. Yeah, because of Laddu, Laddu might love Champa, Laddu might love Pandu. That will create some net love between them. But the intermediate love between Pandu and Champa will not be affected. Yes, the answer should be C for Capto. Oops, many people got it wrong, hopefully, I guess, because some people think, yeah, it should be 1/4 or F by 2 or 0 or something. No, no, no. It will be basically, yeah, be the same. Is that clear, everyone? Understood? Oh, clear? Oh, shall we go ahead to the next question coming up on your screen? Here it is. Two capacitors, come on, this is easy. I want everybody spamming it. Are connected in series, the net capacitance is. So whenever you have two capacitors like this, C1 and C2, then their effective combination CS is given by the following formula. 1 by CS is 1 by C1 plus 1 by C2. A lot of people think CS is C1 plus C2. That is for resistor. Capacitors behavior is opposite. Inductors behave like capacitors. Sorry, inductors behave like resistors. Capacitors are opposite. So use the parallel formula. So if you take the LCM, it will be C1 plus C2 by C1 C2. That is 1 by CS. Therefore, CS will be reciprocal C1 C2 by C1 plus C2, which is D. Yes, D for doctor, D for AIMS Delhi, D for your Diksha ma'am. Perfecto. Amazing. Very good. So many people either write A or they write even this, they forget, or basically C option, they forget. You have to take reciprocal. This is 1 by C. This is not C. This is 1 by C. So when you take reciprocal, this is what you are going to get, which is option number D. Next, the potential at the center of a uniformly charged hollow sphere. Uniformly charged hollow sphere. What do you think it is? Yes, Pradeep, correcto. Yep, come on. Uniformly charged hollow sphere. This is a sphere and it is hollow and it is uniformly charged like this. So the question is on the potential at the center. 0, maximum, equal, depends on the radius. Well. Actually, whatever potential is there here and here will be the same. In fact, V and V will be equal. It will be just KQ divided by the radius of that particular shell. So equal to that on its surface. Yes, it depends on the radius of the sphere is also a correct option. But the more appropriate option is option number C. Even D should have been actually correct, because obviously radius also comes over here. The potential at the center of a hollow shell depends on the radius of the shell as well. Technically, even D should have been correct because R is there in the answer, in the formula. Is that okay, everyone? No, it is not 0. You know what is 0? The 0 answer is for electric field. Electric field is 0. electric field is zero, potential, read the word, potential is not zero, potential is same. All the points inside are actually equipotential. This entire region, this particular entire region technically is equipotential, is equipotential. And the reason why it is equipotential is because of this fact that electric field is zero, so there is no change in the voltage. Field is zero. So be careful, such mistakes can happen, you will lose marks. That is why these questions are very important that you solve them. Next question. The drift velocity of an electron in a conductor is proportional to current, electric field, conductivity, resistance. The drift speed of the electrons in the conductor is directly proportional to, well, there are many ways in which you can look at it. Come on, guys. One formula is current is equal to NVIDIA. Current is equal to NVIDIA. Drift velocity definitely is proportional to the current. Definitely it is proportional to the current. That's one way. You also know another formula of drift velocity, I believe. Remember that formula was something like this. Drift velocity is nothing but E into E, right? Divided by M into the relaxation time. So drift speed is also proportional to the electric field, as you can see. Is definitely proportional to the electric field, as you can see. What about resistance? Resistance definitely not, because you know this fact that V is equal to IR, or rather resistance is equal to voltage by current. If you substitute the value of the current from over here, if you substitute the value of current from here, NVDR, so it is inversely proportional to the resistance. So definitely this can't be correct. Definitely this is correct, and even this is correct. This is also correct. What about conductivity? What about conductivity, guys? What about conductivity? Is it proportional to conductivity? What do you think about it? Is it somehow proportional to conductivity? Come on. Is it somehow proportional to conductivity? Is there a formula for conductivity that we know of? Conductivity can be written down as N, that same N over here, into mobility and into the electron charge, right? So that's how you can write that conductivity as N, mu and E. This mu being nothing but how much is the drift speed? How much is the drift speed per unit electric field? Drift speed per unit electric field and into E. So even drift speed is proportional to electric field. Drift speed is proportional to electric field. So basically this particular ratio which is there, this particular ratio which you can see, this particular ratio will be nothing but a constant over here. So technically you cannot say that the drift velocity is proportional to conductivity. So it doesn't make sense over here. So this is gone out like this. All right, because technically this will become a constant. All right, but if you keep electric field constant, only when you keep electric field constant, then you can say drift velocity will be proportional to conductivity. But how is it possible that drift velocity will be constant? Because if drift speed changes, electric field has to change. So denominator can't be constant. So that is the reason why I'm saying this whole number as such will be constant. So you really can't say it is proportional to conductivity. Is that clear? It feels initially it is proportional, but do not forget drift speed also depends on the electric field. So instead of E, you can also write it in terms of VD. VD will cancel. So it will be not exactly dependent there. So they have put electric field, but actually even A is correct. This is wrong, and even this is wrong. Is that okay, everyone? Absolutely clear? A and B. Yes, A and B options are correct. Perfecto. Moving on to the next question. There is a battery of certain EMF and internal resistance. When this is connected to another resistance, This much 1 ampere current will flow. How much current will flow if the terminals are connected directly? Let's draw the circuit to understand what is exactly happening. There is a battery, okay, of EMF 4 volts. There is some internal resistance which we do not know of, and it is connected to some outside resistance like this, and the current which goes is basically 1 ampere. What is the external resistance? It is basically 2 ohms. So we know current is EMF divided by the total resistance. So 1 will be EMF divided by outside plus internal resistance. So what do I get? 2 plus R is equal to 4. Therefore, R is equal to 2 ohms. So internal resistance, we have got it to be 2 ohms. Now what happens if you take the battery directly 4 volts and internal resistance of 2 ohms and directly connect the terminals? So in this case, the current will be just EMF by internal resistance. EMF is 4, internal resistance is 2, 4 by 2 is 2 amperes. So the correct answer should be option B for your biology or Baswa sir. Yep. Hello Nandu. Yes, this is 12th standard physics. These are not NEET PYQs. These are NCERT based questions for NEET examination. NCERT, because NTA, what is it going to do? It's going to keep NCERT book in front of them and they are going to make the questions. You know, there was one smart kid which I met recently. She was studying in ICSE board, and unlike CBSE, where they have a fixed textbook, right? Fixed textbook, which is NCERT. ICSE does not have a fixed textbook. Every school has a different book. They follow different syllabus, sometimes even different flow of the syllabus. Different things are there. So it's very difficult to predict what paper will come and all of that. So, you know, in the class test, so that kid saw their maths and their physics teachers in the staff room, which book they are using. Accidentally, they went into that staff room for some reason, and the teacher was using some secret book, and they kept that in mind. They bought that same book and they solved all the questions from the book, and they got really good marks in their class test, in their examinations. And that book the teacher did not tell anyone. Yeah, in the class, the teacher used to recommend some other book, but for making papers, he used some different book. And luckily, they saw those books and they just solved all the questions. They got really good marks. So basically, NT has leaked the book, and that is NCERT. So if you know it, you can score really well. As simple as that. Yeah, my name is over here, Captain Shreyas. Yes, that's on Instagram, Telegram, wherever you see, even on YouTube. Okay. A wire of resistance R is stretched to double its original length, the new resistance becomes. Now, this is a most misunderstood question because R is rho length divided by A. Many people think length is doubled, so resistance will double. Rho, actually what happens is the volume will be constant. Volume is area into length. So area is technically volume divided by length. So instead of area, you substitute volume divided by length, and what you will essentially get is rho into L square divided by our volume. So technically, resistance is square proportional to the length. So if somebody says the length has been made 2 times, square of the length has been made 2 square times, so the resistance will be made 4 times. Hence, C for your Capto, C for Captain Shreyas. Is that right, everyone? Got it? Very good. Awesomeness. Yep. Yeah. What happened to A? Which A you are saying? You mean the previous question? What happened to A? Area is volume by length. Volume by length. So I substituted, instead of A, I put it as volume by length. So volume by length, length into length will become length square. So area will become small. When you stretch it, area will become small. So that also needs to be compensated. Many people forget that part. That is the reason why you might get the wrong answer. Okay, next question. A charged particle moving parallel to the magnetic field experiences which force? How much force? F is Q, V cross B, magnetic force. If the velocity and magnetic field both are parallel, what will happen to V cross V? It will be 0. Even the force will be 0. So there will be no force acting on it when they are parallel or even anti-parallel, because cross product means sine theta. Sine 0, 0. Sine 180, 0. So hence 0. Thank you, Nandu, for the 50-second like. Uh, Hi, Sony Mohan. Nice to see you. Yep. Pichaku, Pichakachu. RNA series done, dusted. Whatever topics you feel are, sir, this is not done or that is there, I'll be taking it up as one shot. Like, for example, modern physics, I'll take a one shot of it. Okay, so don't worry, everything will be done over here only. Plus, you can watch my Super 6 classes, which were done, not even last year, this year only, just couple of months back. So just watch Super 6 for the time being if it is urgent. If it is not urgent, no worries, we'll do a one shot on that. Is that okay? Cool. Let's do the next one. Current carrying conductor in a magnetic field experiences maximum force when the angle between the current and the field is. The force formula is I L cross B. This L cross B is as good as saying LB sine theta. So therefore this is the force. But the question is, I want to make this force maximum. That means I have to make sine theta maximum, and the max value is 1 when theta is 90 degree. Hence, the correct answer is 90 degree. Captain Shreyas, is that correct? Very good, Krishna. Awesome. Um, very good, Devi. Very good, Mr. Gaming. Sir, please send DPP. This entire PDF will be available to you after the class. Number one. Number two, one thing which you can use for generating unlimited DPPs. I don't know how many of you know this, but in our DNA batch or even in our NEET Express, there is an option by which you can create your own DPPs on any subject, on any chapter of any difficulty or whatever from any book, and you can create unlimited amount of DPPs. So if you are a part of NEET Express batch, be it station 1, station 2, or even the DNA batch, which is now closed, because now we have started the NEET Express batch, you can create unlimited DPPs from many books. Even the PYQs you can create, non-PYQs, NCERT based, or just CBSE questions, whatever you want, you can create. So use that facility if you are already in the NEET Express batch. If you are wondering where the NEET Express batch is, well, the link is there directly in the description box of even this particular video, like you can see, and it's available at a very good price even right now for just 2,999 rupees. And that feature is there in all these versions. This and this has some additional facilities like test series, and this has even the hard copy of the material which will be couriered to you. Cool. Moving on to the next question. A conducting rod PQ length is moving with some speed in a magnetic field of so many Teslas. A capacitor is connected. Then what is the value of the charge on the capacitor? I'll tell you something. Basically, this is a question on motional EMF. If a conductor moves inside magnetic field, there is a voltage created. So that voltage is called as motional because it is moving, and voltage is generated, hence EMF. And that motional EMF is BLV. Magnetic field 4, length 1, velocity 2. So basically it will be 8 volts. 8 volts. But that is not the end story. What will be the charge on the capacitor? It will be C into V. Capacitance is 10 micro, 10 into 10 to the power minus 6 into volts, which is 8. So this will be nothing but 80 microcoulomb. So that is the charge on the capacitor. It is not 0, and this is not going to increase. So C option is wrong. Even D option is wrong. Now out of this, which will be correct? So for that, you need to know which side will be positive, which side will be negative. Very simple, guys. Okay. See, if the rod is moving like this and the length is like this, magnetic field is inside, just do one simple thing. Do length cross, uh, uh, sorry, yeah, sorry, do V cross B. Just do V cross B. Velocity is towards your right. Velocity is towards your right hand side. Magnetic field is basically inside. Magnetic field is inside. So if you do velocity crossed with the magnetic field, the thumb comes upwards. The thumb will come, the thumb, because of this, the thumb is going to come upwards. That means the EMF is in this direction. The EMF is in this direction. So this side will be positive, this side will be negative. This will behave like a battery like this. This is the negative terminal, this is the positive terminal. So the positive charge will be on A, negative charge will be on B. Hence, option A should be correct, B option will be wrong. Is that okay? How to decide which side is positive? Use V cross B. Wherever V cross B comes, that is the direction in which the imaginary battery can be placed of this motional EMF. So 8 volts battery is like this. That's a simple trick to solve these questions. Got it? Yep. Very good. Awesomeness. Moving on to the next one. Susceptibility of a diamagnetic material. There are 3 kinds of material. You might have heard about it. Dia is the worst. Para, okay. Ferro, the most magnetic material. For dia, susceptibility is having the symbol X. It is small negative. Here it is small positive. Here it is a large positive number. So for diamagnetic, it is a negative. For para, it is positive and low. Positive and high is for ferromagnetic. Hence, the answer should be negative. It is not 0. It is not 0. Correct? Very good. For your little warriors, please take more question solving sessions. Yes, Krishna, definitely. I will be planning more question solving sessions in the near future. Don't worry about it. Yep. Because many of you are done and dusted with the theory. And I want those comments because again, students will ask, sir, again teach from the beginning. If you ask me that, then again, we'll keep on repeating the cycle. And even when the exam is 1 week away, you will be asking, sir, theory again, right from the basics. So understand, we already have made a beautiful playlist on YouTube. Number 1. Number 2, you want more in-depth classes, then you have the NEET Express batch, as well as my recordings, or even the repository of lectures for all the subjects in a detailed manner, which will be a part of the batch. All these options are available. So make use of it. Complete your theory. You have NCERT decoded also. And if there is some topic which is not yet done, or you feel that, sir, I need more theory, that one shot I will take. Don't worry about that. But mainly we should focus now on different problem solvings, PYQs, or even hidden concepts, concept plus question, revision, those kind of things. So that's what we should focus on in the near future, so that we can target 700 plus. Because otherwise what happens on many YouTube places is that students, you will keep asking right from zero. It keeps on happening till the end, and there is no point of doing that. Okay, so let's go to the next one. Magnetic field due to a magnet at a distance x at the on an axis is this much Gauss. Gauss is a unit of field, and 1 Tesla is 10 to the power 4 Gauss. So Gauss is a very small unit. So 10 to the power 4 Gauss is 1 Tesla. The magnetic field on a neutral axis at a distance x from the middle of the magnet is. Okay, let's think about the magnet first. So this is our magnet. Okay, and you are right now over here on the axial point. Let's say this is the point at a distance of x. Later on, neutral point, neutral axis is basically this one. So this is your neutral, which also becomes or equator. This is going to be the equator, and this one is your axial point. And if this is x, the magnetic field at this point is given by 2 times mu naught by 4 pi magnetic moment divided by x cube. Whereas when you are over here, the magnetic field is given by just mu naught by 4 pi m divided by x cube, assuming this is also x. As you can see, everything is same, just the factor of 2. So clearly mentioned over here, this particular magnetic field was 200 Gauss. That is because of that number 2. So if that 2 is not there, how much will this be? That 2 is not there, so just divide it by 2. So it will be just 100 Gauss. So 100 Gauss is A option. Perfecto. A for your aims. A for aims. Yes, correct. E sala aims namde. Correct. Awesome. Awesome. Very good. Yep. You want me to do KTG and Thermo? No issues. We'll take it up as a class. No issues. As one shot. Okay. All right. We'll keep doing those one shots. That's not an issue. Magnetic field. Okay, this is done. All right. In which of the following materials does the magnetic field decrease when placed inside an external field? So you place this material inside somebody else's field, the field reduces. This only happens in one kind of material, the worst material, not non-magnetic. It is a magnetic material, but it is opposite in behavior. It is diamagnetic. In para, it becomes more inclined towards the external field. In ferro, it is even more magnetic and it is even more inclined towards the external field. It will not oppose these two. This will oppose. So the answer is diamagnetic because it opposes and hence the field reduces. Yep, it's diamagnetic. Okay, is that clear? Let's go to the next one. Lenz's law is a consequence. Lenz's law says, or rather it gives me the direction of which side or how the current will be created when you move a magnet inside or outside a coil. So this is induced electricity, the motion, electromagnetic induction concept, Faraday's law. So you move a magnet, current is being created. Which direction the current is being created is dependent on Lenz's law. And it says that the current is created in such a way that it always opposes any kind of change in the flux. If the flux is trying to increase, the current which is induced will create a magnetic field which will try to reduce the flux. If the flux is reducing, it will try to strengthen it. It always opposes. And this is based on the principle of conservation of energy, not momentum, nor mass, nor charge. Is that okay? Kirchhoff's voltage law is also based on conservation of energy. Kirchhoff's current law is based on conservation of charge. Keep that in mind. Current law, KCL or junction law, is based on charge conservation. KVL or Kirchhoff's voltage law or loop law is based on conservation of energy, just like your Lenz's law out there. Okay, moving on to the, oops, my mistake, I showed the answer. Okay, now leave it. A coil of radius r carries current I. The field at the center is proportional to. So my dear students, if you have a coil and this is the radius r and there is some current I, then the magnetic field which is there, is given by mu naught I by 2 times of r. So as you can see, the magnetic field is inversely proportional to r. Yes, this is the formula. Mu naught current by 2r. Standard thing. All right. In LCR circuit at resonance, the impedance is, keep a track of the words, it's resonance. At resonance, XL equals XR. So when you try to calculate the impedance, which is root of R square plus XL minus XC whole square, this will be a big fat 0. So you are just going to get root of R square, which is R. So the impedance is the resistance at resonance. So it is going to be the resistance. Impedance is the resistance. That is option A for aims. Very good, Krishna, Sumati, awesome. ABCD, very good, Susmita, Nalini, Evening Star, very nice. Come on, guys, keep answering. I want everybody to answer. Evening Star, very good, Suganya, awesome. Keep it up. Lovely. I'm guessing you're all loving this particular session of problem solving. And if you want more such different varieties, different concepts, different hidden things, after solving these questions, there should be no model which you will never feel that I have not seen it. Your NEET exam will feel like you already know the paper and it was like leaked on the Vedantu NEET English channel. It feels like that. Yeah, that's the level of confidence that you should get before your NEET exam. The voltage reading on the voltmeter in the circuit shown below, 0, 100, 200 or 300. Okay, so we have a resistor, we have an inductor, we have a capacitor, 150, 150. Okay, see this clearly. The voltage across the inductor is the voltage across the capacitor, which is 150 volts. So when you draw the phasor diagram, VL is over here and VC is over here. So they both will end up cancelling out each other. The only thing which remains is voltage across the resistor, which will also become the total voltage. The total voltage is 300 volts. So voltage across the resistor will also become 300 volts. So this is the resistor, this is the voltmeter. So it should record 300 volts. I know many of you think 0, and I'll tell you why. Because you think, oh sir, this is 300, this is 150, 150. So out of 300, 150, 150 already makes it 300, so nothing will be there here. No, you can't add the voltages in AC like that. They are vectors. Just like 5 Newton plus 5 Newton, maybe 0 Newton, maybe 10 Newton, maybe 5 Newton, maybe 6 Newton, because the direction matters. So here the phase matters. That's why you draw phasor diagram. You can't add voltages like scalars in AC. In DC you can. AC, treat it like vectors. Got it? Clearo? Moving on to the next question. Awesome. Moving on to the next question, guys, coming up on the screen. The power factor of a purely capacitive circuit. When I say purely capacitive, means the voltage across the capacitor in the phasor diagram is here, the current is over here, the phase difference between them is 90 degree. The power factor cos theta or cos phi, whatever you want to call it, cos 90 will be 0. So this is your power factor. Power factor will be basically a big fat 0. 0 means option A for IMSS. Yep, wow, looks like IMSS is on demand. Most of the options are A for IMSS or D for Delhi, I guess. Okay, and C for Capta is also there. Biology, okay, everything is there. Which electromagnetic wave has highest energy? This is a question based on the electromagnetic spectrum. Okay, let's try to recollect electromagnetic spectrum. Well. Highest energy means frequency should be more. Low energy means frequency is less. So energy more means frequency should be more. If you see ultraviolet, infrared, gamma rays, X-rays, infrared is basically low energy, low frequency. Then you will get your ultraviolet, yes, somewhere over here. Then you will get basically your X-rays over here, X-rays over here. And finally, gamma rays are the most energetic. Gamma rays, yes, gamma rays are the most energetic. They are produced from nuclear reactions and all of that. So yes, it should be B option. More frequency, more energy. Wavelength wise, they are the least. Less wavelength, more frequency. This is wavelength wise more. You should know the electromagnetic spectrum. If you know it, you get it, else you will be stuck. Displacement current in a capacitor arises due to displacement current. Remember, there is two currents. One is conduction current. It is due to the flow of the charges. Then you have displacement current. Why is that? Due to the change of electric field. Yes, due to the change of electric field. Correct. So hence the correct answer for this is time varying electric field is the reason for it. Got it, my dear students? Excellent. Very good. Very good. Awesome. Awesome. Moving on to the next one. Focal length of a plane mirror. Oh my God. What is this? Come on. If you have a concave mirror, the focus is over here. if you have a convex mirror, then the focus is over here. Then think about it, if you have a plane mirror like this, then there is no focus, or think as if the focus is at infinity. So hence the focal length will be infinity, which is option A. Got it? It has a focus at infinity. It's like saying it does not have focus. See, in mathematics, if you use the word infinity, infinity is just a polite word of saying no to someone. But means it does not have a focus. Obviously, where will it focus? It will not focus. A plane mirror. When you say, when your teacher asks, when are you going to submit the assignment? One student says, ma'am, I'm just going to submit it in DT time, means right now I'm submitting it. Another student says, ma'am, I will submit it after delta t is equal to 5 seconds. Maybe he's doing something, he finishes it and submits it within 5 seconds. Another student, ultra legend, says, ma'am, I will submit when t limit tends to infinity. Teacher says, okay, you will submit at infinity. Where is infinity? It's not there anywhere on the watch, clock, anywhere. Infinity means I will not submit it. It was just a polite mathematical way of saying I will not do it. Got it? Okay, everyone. Condition for constructive interference in thin film. Oh, sorry. In any kind of thing, constructive interference means the path difference should be integral times of lambda. Integral times of lambda. If it is destructive, then it is odd times lambda by 2. Constructive is n times lambda. Destructive is odd times lambda by 2. Correct. So that was that. Two waves of intensity 9:1 interfere, produce fringes in YDSE, Young's double slit experiment. Maximum and minimum intensity ratio. Standard question so many times. It's even there in NCERT. You can see I max by I minimum. You should know the formula. What is the formula for I max? Root I1 plus root I2 whole square. I minimum root I1 minus root I2 whole square. So the intensities are 9:1 ratio. So I will write root of 9i plus root of I and root of 9i minus root of I whole square. What will this be? Root 9 is 3. So this will be 3 plus 1 root I whole square upon 3 minus 1 root I whole square. 3 plus 1, 4. So 4 root I. 3 minus 1, 2. So 2 root I the whole square. 4 by 2, 2. Root I cancel. 2 square is 4. So it is basically 4:1. 4:1, option A, I believe. Yes, that is the correct answer. That is the correct answer. This is one common question. Sometimes they give you this and they ask you, what is this? Sometimes they give you this and they ask you, sorry, they give you this, they will ask you this, or they'll give you this and they'll ask you this. Either they will ask you the intensities of the interfering waves, or they'll ask you the intensities of the resultant waves. Both of them have similar type of solving. It's just that what is being asked and what is being given. Formula is the same. You should know this. In the Young's double slit experiment, what does the fringe's width depend on? Fringe width, how big is the dark or the bright fringe? Formula is lambda d by small d. Wavelength of light, yes. Distance between the slits, yes. Small d, which is basically the distance, capital D is distance from the screen. Distance between the slits is small d. So this is small d, this is capital D, this is lambda. So definitely all of these, D for Delhi, D for doctor. Very good. Very good, Pratibha. Very good, ABCD. Yeah, sometimes Ritvik correct for amplitude also. In 2024, many questions came from this type of question solving classes. Hope in 2025 also maximum questions will come from my question solving. That's the hope. And it's not just in 2024, it also happened in 2023. And in JEE, so it has been happening for many years. So if you are just solving the questions, you will 100% feel like you have seen these questions in Shreyas sir's class. So usually people tell me that, sir, this is what I have felt. And this year we'll even put more efforts on problem solving, because our theory content is there on YouTube also already. So you can keep utilizing those lectures, obviously. photoelectric effect proves. What does it prove? Einstein used the photoelectric effect and he won a Nobel Prize for something. Until 1900s, people used to believe light is a wave, and it was proved light is a wave by Maxwell's equations too, and light was an electromagnetic wave. But Einstein said that no, light also has particle behavior. In fact, the particle behavior of light, which was again given by Planck's that photon model, was basically that particle of light was called photons. And then finally it was concluded light has dual behavior, both personalities. Yes, the particle nature of light, which is called as photons, hence the name photoelectric. Photons, electricity producing effect. Okay. De Broglie wavelength is inversely related to what? The de Broglie wavelength is inversely related to what? Lambda is h by p. P is momentum, h is Planck's constant, which is h by mv. Inversely proportional to velocity, mass, momentum. In fact, all of these you can say. All of these you can say. So it should be, oops, I should actually put all of these. I don't know why this answer was marked as C. My bad. This I will delete. It is basically all of these. All of these. Yes, inversely proportional to mass, inversely proportional to velocity, inversely proportional to momentum also. Very, very good. Awesomeness. Moving to the next one. A particle of mass 3m splits into two particles with some velocities. What is the ratio of the de Broglie wavelength? This is amazing question. I'll tell you why. Imagine this was a particle whose mass is 3m and right now it is at rest. That means the initial momentum is 0. Now it splits into two masses. One is having a mass of m, another is having a mass of 2m. So this will have some velocity, let's say v2. This will have some velocity v1, such that the final momentum should also be 0, which means the momentum of 1 and the momentum of 2 magnitude wise should be equal, but they should be opposite. They should be opposite. And why should they be opposite? They should be opposite because they have to cancel and give the final momentum as 0. Why is the final momentum 0, you might ask? The reason for that is because initial momentum should be final momentum, that is by conservation of momentum. That is by conservation of momentum. This force of explosion was an internal force, so total momentum finally must be 0, which is the total initial momentum. So the momentums are equal. Hence, what about the de Broglie wavelengths? The de Broglie wavelength, lambda 1 is h by p1, lambda 2 is h by p2. But wait a minute, this p2 and this p1, they both are equal. Hence, this lambda 1 and lambda 2 are also going to be equal. Hence, answer is D. Got it? Everyone? Such an amazing question. Such a beautifully framed question, completely based on de Broglie and momentum conservation. Sometimes multiple concepts can come together. So that is the reason why you should attempt all these questions, study with me. Every model, solve it 1-2 times, 1-2 times. If it is not clear, 3 times, 4 times. Solve it. I'm telling you the trick. Just keep solving. Just keep solving. It's not going to be a difficult paper. And I gave you a detailed analysis yesterday. I don't know how many of you saw that on the channel itself, where I told you how much percentage is going to be difficult, how much percentage is going to be easy, medium. A proper analysis was done right over here. Revised NEET pattern, scores, difficulty, everything. I have given the PDF also. I mean, what more you want, yaar? Come on. What more you want? It is there. Expected PDF is there completely attached in the description box. Even in the comments, I believe it should be there somewhere. Yes, it is there in the comments as well. So check it out. It will help you a lot. You will understand that even if you don't solve the very difficult questions, still you will get very good score. It's just 18% difficult questions. But I know with time you will crack even the difficult questions, and we are targeting 700 plus. We are not targeting 600. Zener diode, what is it used for? Zener diode, it does Egyptian dance like this, isn't it? Like this. Like this, it does Egyptian dance. Like this, it does Egyptian dance. Yes, Egyptian dance. What does it do by doing Egyptian dance? It regulates the voltage. No modulation, no amplification, no rectification. It regulates the voltage. It is used in reverse bias. Yes, it's used in reverse bias. Chumma, I am doing it. Sometimes, NEET, NTA is very weird. They can give borderline questions. So better do it. Borderline. Zener diode, okay. Just have an idea. Nobody is going to ask you a diagram and all that. Sir, is it deleted, not deleted? That's another thing. Just do all the borderline questions. I have mentioned that also in that video. Conductivity of a semiconductor will increase with. See, semiconductors and conductors are completely opposite. For conductors, when temperature increases, the resistance increases, conductivity decreases. Whereas for semiconductors like germanium, silicon, etc., when the temperature increases, the resistance will decrease, the conductivity will increase. It's exactly opposite. Hence, the conductivity will increase when the temperature will increase. That is option B. If you make this small chart, you will not get confused. Or the temperature increase or this will decrease or increase. Oh my God, what is happening? Don't do all these stupid things. Write it down properly in rougher. For conductors, this happens. I know teacher told me, Shreyas sir told me it is exactly opposite for semiconductors. So write it exactly opposite. Done and dusted. Okay. Oh, that was the last question, I believe. And NCERT has been decoded. This was just first session, guys. We'll have more such NCERT decoded sessions. Do you think this is the last one? Obviously not. We need to decode even more concepts from NCERT. Be it the back exercise, be it the exemplar, be it the in-text already done in our NCERT, line by line series. So as many things as we can, PYQs, non-PYQs. Are there some models which can be most likely asked from very old kind of questions or old PYQs or AIMS or JIPMER papers? All those things we will do it on the channel. But I want this comment after the video, NCERT decoded. Okay. Thank you so much. I hope you have liked the video, enjoyed the video. That's more important, and learned a lot. And like this, let's continue learning with your Captain Shreyas sir. Okay. And do not forget to check out the recent videos on the syllabus, which has been deleted, official updates, also revised safe score and difficulty, which will help you understand. All the PDFs have been put up in the description box as well. Okay, so make sure you check it out. All right. Bye bye. Take care. Hasta la vista.